Hello again. We had stopped this section right on this problem, this example C. And I left, remember, when I finished, I said I will show you a different way. Because we have to be careful when you have an extra number here that could be broken into a power. So this is our answer, but I'm going to show you a different way to do that. It still involves working with 8 and breaking it down into 2 to the third. But the first thing that might occur to you is to change that square root into a power of 1/2. So you have 8 raised to the 1/2. Then you use the power rule and you bring the 1/2 in front. So it'll be 1/2 log base b of 8. Then hopefully you remember 8 is a number that can actually be broken down into, by a base. So we keep going and we have 1/2 and we have log base b of 2 to the third. So that's a power again, so that goes in front. So you have 1/2 times 3 log base b of 2. And then you need to think of that 3 as being 3 over 1, and it will give you, you multiply 1/2 and 3 and you come up with the same answer. Now either way, you have to deal with 8 eventually and break it down into 2 to the third. However, if you have variable expressions, you probably don't want to do it in 2 steps like we did here in red. I'm talking about this particular example here. And in that, it would be log base 2, and it's x raised to a power. The power inside becomes the numerator of the fraction, and the index of the root, I'm referring to this number here, that's what we call the index of the root. The index of the root actually becomes the numerator. So the power is actually 4/7, x raised to the 4/7. Then you use the power rule and you bring the 4/7 in front, so it would be 4/7 log base 2 of x. And that is the power rule. Now, the special rules or inverse properties, we've seen some of them before. This one, in fact, is the one that we did in section 11.3, and that's when you had something like log base 2 of 2 to the 5th, and it gives you just 5. So it's called an inverse property because log and exponents are kind of reverse of each other. So you're taking log base 2 of 2, raising it to a power. So it's almost like everything cancels out, the log, the base 2, and it gives you the exponent. Now in this one, the opposite happens. You have b raised to log base b of x, but notice that you still get x back. And so the reason for that is because raising a base to an exponent will be the reverse of taking the log of the same base. So they kind of cancel each other out. This one is not as common, but it's kind of doing the same thing. You could have something like 3 log base 3. So see, the bases are the same. And then you have something else here, like maybe a 5. So the base 3's and the logs cancel each other out, and it will give you a 5. Okay, let's look at some more examples of those. And let me go ahead and make this a little bit bigger. Oh, no. Let's see. Let me try that. Okay, it says use the special properties to rewrite each of the logarithmic expressions. So you have log base 3 of 3. It will be exactly equal to the exponent. This one, log base 2 of 8, you have to change the 8 so that we use a common base of 2. 8 is 2 to the third, so now you have log base 2 of 2, so it gives you just the exponent. And this one is like the one we had before. Notice you have a base of 5, log base 5, so everything cancels out except for the 9. Now here's a summary with all the properties. You have the product rule. Remember, that's the log of a product. It changes it into the sum of two logs. Quotient rule is the log of a quotient or fraction that changes into the difference of two logs. The power rule takes this power, it gets rid of the power, and it makes it into a multiplier, a coefficient. Then you have the inverse properties. Log base b of b to the x gives you the exponent, log equals exponent, or b raised to a log of the same base, it gives you x. And then these ones are the ones from section 11.3. Don't forget about those two. Log base b of b, the exponent must be 1. Log base b of 1, the exponent must be 0. Okay, so now we're going to look at some examples that use all of these properties together. Maybe not all of them together, but more than one at a time. It says use the properties of logarithms to rewrite each expression if possible. Assume all variables represent real numbers. Okay, so the first thing we need to do is we need to realize that 36m to the 5th really means log base 6 of 36 times m to the 5th. So it's a multiplication, it's a product, so then we use the product rule and we're going to change it into a sum of two logs. So we have log base 6 of 36 plus log base 6 of m to the 5th. And the first thing that catches my eye here is that 5. So I know with the power rule that's going to go in front. But the 36 and the 6 have a common base. So I'm going to rewrite that as log base 6 of a 6 squared plus log base 6 of m to the 5th power. And so now, since the bases are the same, this whole logarithm is actually equal to 2. That's that property that we started in section 11.3, but also the inverse property. And then in here, we're going to move that 5 to the front. So that will be plus 5 log base 6 of m. Now, don't try to add the 2 and the 5 together. The 5 belongs with the log base 6 of m's, and it cannot be separated. Now, here's another example, and this one has a square root, so we know we have to turn square roots into powers. So that will be log base 2 of 9z raised to the 1/2. You can do the power rule now, but if you do that, make sure you realize that everything that you do after that will be affected by that 1/2. That's okay. But if you break the log base 2 of 9z, because this really is a multiplication, then you're going to have to multiply by 1/2. So what I'm going to do is I'm going to put the 1/2 times, and then in brackets, I'm going to break the log base 2 of 9z. So that would be log base 2 of 9 plus log base 2 of z. And then I'm going to go ahead and distribute the 1/2. And you can go ahead and distribute the 1/2. You might also look at the 9 and see if you can break it down. I would recommend you distribute the 1/2 now. So you have 1/2 log base 2 of 9 plus 1/2 log base 2 of z. But you want to start trying to catch situations like this. If you can break the 9 into a base, raised to a particular power, then that means you can actually continue. And by the way, that's a 3 square. So I'm going to change that into 1/2 log base 2 of 3 square plus 1/2 log base 2 of z. Then I'm going to go ahead and take the 2 in front, and 1/2 times 2, they're going to cancel out. You're going to have 1/2 times 2 log base 2 of 3 plus 1/2 log base 2 of z. Then the 1/2 and the 2 are going to cancel out. So we have, right there, we have actually just log base 2 of 3. And I made the mistake right there. Let me go ahead. Log base 2 of 3 plus 1/2 log base 2 of z. And that is your answer. Now I'm going to go ahead and draw some lines here to separate that. To work on this next example. Okay, so in this next example, you also have a square root, so I'm going to change that into log base 2 of xy over z raised to the 1/2. And we can put the 1/2 in front, but do it like we did here with the 1/2. So I'm going to put the 1/2 right here for now. Log base 2 of xy over z. But anything you do to break that log down now will be affected by 1/2, will be multiplied by 1/2. So I'm going to actually put brackets in there. 1/2 times, and it's a fraction. That's a fraction right there. It's a division. So I'm going to break it into the log of a difference. Log base 2 of xy minus log base 2 of just z. And we still have a multiplication here. So I'm going to continue in the next step and work now with the product rule. So that will be 1/2 log base 2 of x plus log base 2 of y minus log base 2 of z. And then in your final answer, you're going to distribute the 1/2. So you have 1/2 log base 2 of x plus 1/2 log base 2 of y minus 1/2 log base 2 of z. Now here is another example, and this one is log base 3 of x cubed z over y squared. So we have, that is a quotient. So I start right away and I break it into a difference. So I have log base 3 of x cubed z minus log base 3 of y squared. And I'm going to take care of the powers, but I'm more worried about the fact that I have a multiplication here. So I'm going to use the product rule. So I have log base 3 of x cubed plus log base 3 of z minus log base 3 of y squared. And then now all I have to do is take care of the exponents, the powers here, the cube and the 2, and those become coefficients. So you have a 3 log base 3 of x plus log base 3 of z minus 2 log base 3 of y. And that would be your final answer. Now this one here is actually a little bit misleading, because we should have some different instructions here. We should have some instructions that say write as a single log. In other words, do the opposite of what we have been doing. Because if you notice, it's already broken into 2 logs. Now we're going backwards and we're wanting to write that as a single log. So we think about order of operations. And this means 2 times the log of base a of x plus 3 times the log base a of y. So the multiplication would come first in the order of operations. So think about how we could get rid of that 2 and that 3, and you might think actually about the power rule, but in reverse, the opposite of what we're doing in here. So that becomes log base a of x squared plus log base a of y cubed. Now the operation between them is that plus, so that becomes log base a of multiplication, and that will be x squared times y cubed. There's no need to put that in parentheses, but if you want to do it, that will be okay. Now this one we go back to, rewrite using the properties of logarithms, breaking it down. And we have log base 4 of 3x plus y. But this is actually a trick question. There is no rule that allows you to break down the log of an addition or a subtraction. Even if I had log base 4 of 3x minus y. This is already in simplest form or cannot be simplified. Now, don't tell me no solution, because this is not an equation. Just tell me that it cannot be broken down any further. There's no rule for the log of an addition or a subtraction. Okay, now here are some more examples, and these ones are the kind where you are asked to rewrite as a single log. So you're going backwards from most of the ones we did before. So we start with order of operations. That will be 2 times the log, 3 times the log, and then the addition. So we do that power, that coefficient first in the power rule. So that would be log base 9 of x squared plus log base 9 of x minus 5 raised to the third. Then we take care of the addition, that's the next operation, and that becomes log base 9 of x squared times the x minus 5 cubed. And in algebraic expressions like that, there's no need for parentheses for the whole thing, but if you feel more comfortable putting parentheses right there, that will be okay. So when we're doing this process in reverse, it looks like taking care of the coefficients and changing them into powers is what we do first. So we do that here, and that would be log base 3 of x squared plus log base 3 of x minus 1 raised to the 1/2 minus, and keep the minus there, it will be 4 log base 3 of 2x plus 5 raised, but I want to get rid of the 4. Keep the negative, but not the 4. Let me make that a little bit smaller. So that would be log base 3 of 2x plus 5. Keep the negative, but take the 4. And now at this point, that's where we start making mistakes. And you don't have to do it in several steps, but you're going to have to group them from left to right, just like you do in order of operations. So this would be log base 3 of x squared times x minus 1 raised to the 1/2, and then minus log base 3 of 2x plus 5 raised to the 4th power. Now we take care of the minus, so that will be log base 3 of x squared times x minus 1 raised to the 1/2 over 2x plus 5 raised to the 4th power. If you want to change that square root into in that 1/2 into square root, that's okay, but that will be the rest of it. So you're going to have questions ready from this section, section 3.4, as well as 11.4 and 11.3 for me on Monday when I get back, but we are going to move on to 11.5.